Okay, everyone can hear me all right? Perfect. So my name is Nader Dabit, and I'm here to talk about hybrid scaling solutions for Web3, essentially trying to reach like Web2 scale in reality today, not theoretically and not we are thinking about, and this is how you can do, but how to actually get there right now. So the implementation I'm going to talk about is something we've done with Lens, but theoretically it's more about like opening your mind and thinking outside of the box. And what I'm going to be talking about here is really the work that's been done by the Lens and the Aave engineering teams. I'm kind of here just explaining what they've done and hopefully kind of doing a good job of that because they're the ones that really innovated here and came up with a lot of this or all of this. And I'm lucky enough to come here and talk about it. So if you want to follow along with any of the things that I'm talking about in terms of our blog, our documentation, our developer docs, our grants program in terms of Lens protocol, you can also get all of the code that I'm going to be showing here from our GitHub. And this is a link tree, and hopefully it will, let me get out of the way, take you to some of that stuff. So to introduce the underlying technology that we've built, I first want to just do a quick intro of Lens. And my name, again, is Nader Dabit. I'm the director of DevRel at Aave, and I work very closely with Lens Protocol, and I've been doing developer education for 8 years, and I've been a software engineer for 11 years. So Lens, when I'm talking to developers, I would say it's more of a protocol and a suite of tools and APIs for easily building social apps or integrating social features into existing apps. The general thing that we say Lens is to the general public is it's the social layer of Web3, but really it's kind of in terms of the difference between a traditional social app and then what Lens is, it's more of a developer platform. You could compare it to something like Auth0. You could compare it to something like Vercel. You could compare it to something like Amazon Cognito in terms of it being a service that you can build applications with. And I first want to quickly introduce a big thing that we launched that was enabled by some of the technology that I'm going to talk about in just a moment that was announced here a couple days ago from Stanny, who's the founder of Aave and Lens V2. We have about 5 or 6 slides I'm just going to touch on that have been updated here. We've implemented something called Open Actions, and Open Actions allow you to interact with any smart contract from within a Lens application. So for instance, you can borrow and lend and interact with all of the different DeFi protocols directly from a social app. You can mint NFTs, you can interact with OpenSea, you can join a DAO, you can vote, you can interact with oracles. So this is unlocking a lot of interoperability and composability, I think, with what Lens had offered in the past. We also have collective value share, and this is just going to be a much simpler way for developers to monetize their clients. So developers right now don't really have a straightforward way to monetize the transactions that are happening on their clients. And one of the things that Lens enables is a lot of different clients. So we have Orb, who's the founder, is here in the back, that is one of the most high quality mobile apps on the Lens ecosystem, getting a lot of traction. We have Lenster, we have Butterfly, there's quite a few out there. So we want to make it easier for people to monetize all over the place. So this is also enabling more stuff really across the board, but I would say the most interesting thing for me, it's more for application developers. We also have a new implementation of profiles that kind of really changed the really base infrastructure from how they were configured in the past. And one of the interesting things that we are enabling through this is open namespaces. So we don't want to be only .lens. We want to support ENS, and we're going to start supporting ENS. We're also going to enable infinite namespaces. So you could basically start a company and use Lens as the infrastructure, and then you can have a whatever, like .xyz, .consensus, .polygon, I don't know, whatever you could possibly think of. So this is going to basically open the doors to a lot of innovation, I think. We also implemented something called Profile Manager. This is delegation, essentially. So the problem right now with a lot of companies is that they want to use Lens, and they can't just mint a profile and let their employee use it, because then they would have to hand over the private keys. Also, if you have a profile and you keep it in your cold wallet, which is probably what you would want to do as you build your reputation, you would not be able to easily use the application. So now you can basically just go in, delegate to a bunch of addresses, and then use those addresses. So you might store your profile in a cold storage, and then delegate to a hot wallet. We also launched a new website. So we have a new claiming page, which is something that a new waitlist app and a claiming page, which is something that we've been really wanting to have. And this is a really simple way for anyone in the world to basically sign up to get a lens handle. Whereas in the past, it's been more of a walled garden, a very closed beta. We're trying to open that up a lot. Okay, cool. So now we're going to talk more about the point of this talk. And to kick this off, like the question that I'm going to start with is like, what is Web3 social? And I struggled to answer this because it's a lot of things, but I actually ended up going to Anthropic, and Anthropic is essentially like a general like LLM similar to ChatGPT. It does a really good job on really recent information though. And I kind of like concisely put together this definition: social platforms and applications built using blockchains, decentralized networks, and token-based economies rather than centralized platforms. I thought that was a pretty concise answer and pretty straightforward. What are the value propositions of Web3 social? Portable social graph, this is for users, like the person that would be using an app like Twitter or something like that. Portable social graph, client diversity, a variety of recommendation algorithms. So with Twitter, a lot of people have gotten the new updates and they're not happy with the content that they're seeing. With more public data sets, and what we're now seeing with about a dozen or so teams building recommendation algorithms on Lens, we're moving, and we're going to actually have the ability to like go into your settings and just change the recommendation algorithm. So instead of like being fed up with an entire app and leaving that entire ecosystem, you can kind of stay there and just choose the content that you want to see. And this is something that Jack Dorsey has been talking about for a while now, that I'm sure Nader is kind of moving towards, and they are kind of in a similar vein in terms of like what they're doing there with Nader, I would say, is what we're doing with Lens. And then finally, direct financial relationship with your audience. So this enables you to kind of like cut out the middleman in terms of like monetizing your content, but also enables people that are trying to advertise to directly connect with influencers. And then I would call out one more thing, would be something like being able to go to sleep at night knowing that your profile and your identity isn't going to be deleted. So with any centralized database, obviously anyone can just go in and lock your profile or delete it or something like that. This happens quite a bit. So with Web3 social, you have what you might have heard called ownership, when in reality it's more just like censorship resistance, meaning no one can delete your content. And then for developers, managed / serverless infrastructure and services. So again, I would kind of very much compare what we're doing to what Auth0 has done with identity, and what AWS has done with serverless functions, and what Vercel has done with hosting web services and stuff like that. And we're applying that same idea to social features. And when you think about the fact that almost 5 billion people in the world are using social applications, this is a very big user base. With developers, they really like the fact that there is a built-in user base, so you don't have to bootstrap your audience from scratch. Right now in a closed beta, we're already over 100,000 users. Developer velocity, meaning you don't have to worry about, since you don't have to worry about building the back end, you can focus on building the web or mobile client, and therefore you can build more quickly. And a result of that is just being able to experiment more quickly and at a low cost. So why is any of this important, and what does this have to do with Web2 like scale and what I'm here to talk about? Well, I want to go back to 2022, and this talk is from Adam Mosseri. And Adam Mosseri is the head of Instagram, and he's also who launched Threads. And Threads is a new social network that is the first time I've seen at scale someone take a Web3 idea and implement it in the Web2 space at this scale. And what Web3 idea did they take? They took this idea of a portable social graph and made it a reality. People on Instagram had built their following for the last 10 years, And he launched a Twitter clone where people can just take their social graph with them. And that was a big deal. Like, they were able to onboard over 100 million users within a week or two. And Adam Mosseri is very like Web3 native and bullish on blockchains and Web3. This is a very interesting talk if you want to hear it. It's kind of ahead of its time. He's the one that launched Threads. And then he said, what does it cost you in terms of, like, speaking of Web2? You're beholden to each platform where you show up. You are playing by the platform's rules. He's hinting, like, without trying to say, like, dive too deep into the Web3 stuff, because I think it's still kind of, almost a landmine in that space to kind of be too bullish on Web3, But they are hinting more and more towards this. And it led up to when Threads launched. Now they are going fully into this area of decentralization. He posted on Threads a few days after Threads launched that they're actually building Threads to be a decentralized network. And he then goes in to say, here's a reason. You might end up leaving Threads. You might be deplatformed. He's hinting at portable social graphs. He's hinting at censorship resistance. Being able to port your social graph, essentially, is kind of a value proposition. But you obviously don't see, I think, these sorts of companies fully embracing blockchains, because then they have no control. So instead, they're using something called ActivityPub, which is kind of, I'll talk about the trade-offs more in just a moment. And then you also have Jack Dorsey, who founded Twitter, then he founded Blue Sky, and now he's more all in on Nader. So the two biggest founders in the history of the world of social are building decentralized social applications. One of the things that is interesting to me is the founder of the internet, like some people would kind of like say that about Tim Berners-Lee, is also building a decentralized social network called Solid, which is social something decentralized. I forgot what that acronym is, but it's basically an acronym. And I saw an interesting write-up about why Meta chose ActivityPub. And again, it's the fact that it has some of these characteristics of decentralization without them losing full control. So in this breakdown, it says it plays to Meta's strengths. Meta will still control the identity layer even when it integrates with ActivityPub. And then it goes on to say, ActivityPub decouples many key building blocks: identity, moderation, and ranking algorithms. So ranking algorithms and recommendation algorithms and things like that are really, really going to become more and more of a thing and more important as we move forward, in my opinion. Because people, for the first time ever, have a variety and have the choice of that recommendation algorithm. So I think it's safe to say that we're kind of getting here with decentralized social, and Web3 went through that hype cycle where it got really popular and then it went down, and you could call it crypto, you could call it blockchain, whatever you want to call it, I don't care. But let's just say decentralization, it kind of went through that hype curve, and I feel like it's starting to maybe like come back like this, and we're going to start seeing some big apps, building in this way. So the question now is, how do we build it? Well, should we build it on blockchains? I don't know. Like, that's a good question, and I have an opinion about that. And I would say, if you look at the scale that we need to accomplish this, you can't build it on blockchains. I worked at AWS for over 3 years, and we had applications that were doing millions of transactions per second for a single application. And in Web3, we have blockchains that can only do a few hundred transactions per second shared between thousands of applications. And we've never seen an actual blockchain scale to that level ever. There's a lot of people who will launch a token in a blockchain and they will say, oh, we can do 50,000 transactions per second or whatever. I mean, they don't even claim that, but let's say they claim 10,000. It's actually never been tested, and most of the time when you actually look more closely, there's a lot of like bullshit and nuance that they basically completely skim over, because it's almost like impossible to reach. I mean, it is impossible right now to reach that scale, but it's also not possible to reach the scale that a lot of these companies are claiming, I would say. So what's the answer here? Well, let's talk about why blockchains cannot scale to this, I would say, scale that you need to be. And some of the work that I'm talking about, again, is from most of these ideas that I'm going to talk about from here on out come from the Lens engineering team and what they've built with the technology that I'm going to talk about in just a moment. So you have shared block space, you have max block sizes, and you have like a latency on when these blocks can finalize. And when you start kind of looking more closely, you imagine that the types of situations that happen in the real world, like at 3 o'clock in the morning in the US time, or let's say like 1 o'clock in the morning in the US time in Europe, it's still early, like there's not a lot of usage on these social networks. And then you might have something like the World Cup where there are 50 million, it was like 50,000, I think, operations per second on Twitter. So you kind of have these massive scaling events. But with blockchains, the way that this typically works is that the more demand that you have, the more resources that are needed, obviously, and then therefore often you end up having more of a cost for each transaction. And the bottleneck here is the storage. So blockchain storage is more than storage, it also is state. And when you're paying for this state, you're also paying for the network to come to consensus for every single transaction that happens before the next transaction can finalize. And what you're basically doing here is preventing like this idea of the double spend problem, which is really important in DeFi, it's really important in finance, but it's not that important in terms of storage, right? Because in terms of storage, if I store something and then my friend stores something at the exact same moment, it doesn't matter who settles first. All that matters is the other characteristics that a blockchain provides: censorship resistance, immutability, and I would say censorship resistance, immutability, and there's one other characteristic that my mind is blanking on that I was going to outline. Anyway, I'll remember that in just a moment. But generally, you have those needs, but you don't have the need to prevent the double spend for something like data storage. But the way that blockchains traditionally are architected is that they have that bottleneck, right? So blockchains, therefore, are not the best storage mechanism. If you can basically extract those other characteristics and use them for what you might need them for. And mainly, we were building in the past on the EVM, and the EVM is just a big state machine, and we basically built on Polygon. And we still build on Polygon. Polygon is where our financial transactions, like someone tokenizes something, or someone pays for something, someone collects something, etc. So the EVM enables trustlessness. When you generate a new address, it generates a public key and a private key. The private key is used to sign the transaction and prove you have access. When you do a contract call to transfer something or to make any interaction, you're basically signing the transaction with your private key. The EVM's power is private keys, which are never on-chain. They're always off-chain. So if the EVM is basically a state machine with off-chain keys to prove that you can do something, it forces costs when you want to change the state. And it does not charge anything to simulate an actual transaction. It only charges it to actually finalize a transaction, because the EVM has this idea of simulation. You can basically check to see if something is going to actually happen before you finalize it, right? So you could basically use some type of simulation software, theoretically, to leverage the EVM, which is basically used to, in the past, simulate and then transact on the EVM. But what if you simulated on the EVM and then transacted elsewhere, but you took all of that information that you were given without having to actually pay the gas? So what the team came up with is based on this kind of like realization that if the keys are off-chain and you can sign off-chain, you can simulate off-chain, then these transactions can be essentially run for free. So instead of actually storing on a blockchain like the EVM, you can simulate on the EVM and store elsewhere on a less expensive network. And what we chose to build with is a combination of Arweave and Bundler. So we're simulating essentially on the EVM and then storing on a less expensive network. Arweave is a permanent storage layer. It does a lot more than that, but that's kind of the base idea. And it's been around for 6 years. It's not one of these things that launches and is like, oh, we're going to do this, and then you don't really know. And for data storage, this is very important to kind of be able to look back, and the longer something is around, the more that's trusted. So S3 has been around for, I don't know, 20 years or something. So people recognize how important that is, and therefore it might not be the best solution out there, but a lot of people use it. It's kind of cheap and all that. It's decentralized. It enables censorship resistance, it enables immutability, and it enables permanence. But it doesn't support EVM addresses. But Bundler Network actually does. Bundler Network is a protocol built on top of Arweave that you could think of as kind of like an L2 or an L3, whatever, on top of Arweave. It essentially bundles transactions, and it enables fast finality, 8 millisecond finality. And right now it scales to around 50,000 transactions per second. And they support EVM addresses. So you can basically pay fees in any of the supported ERC20 tokens. They support like 10 or 15. They also support Solana and others. And what was built was this solution called Momoka. And it's essentially, concisely, a hybrid scaling solution for Web3 to achieve Web2 scale. Oops, that's my, oh shit. Why am I, let me jump forward. Okay, sorry about that. Here we go. And the Momoka flow looks something like this. In the past, you would sign a transaction, post it to Polygon. That's it, right? And then you would have an indexer like pick that up, and you would query from it. The new flow introduces these two new components, submitter and a verifier. The user signs a transaction, sends it to the submitter. The submitter then takes over from there. Submitter simulates a transaction on Polygon, gets the metadata back, and then post that data to a data availability layer, or whatever you want to call that. Data availability is a nuanced term. People will argue about like what exactly that means, but it's a data storage, let's say a data storage layer. And in our case, it's Arweave with Bundler Network. We then have a verifier that's a listener. So the listener will basically have some type of port open listening for those updates. And when that happens, it will verify the proof to make sure that the metadata that was simulated is actually true. So we simulate from the submitter, and then the verify also simulates. And then if that is a verified transaction, then you have an API layer that would like then pick that up and then enable it to be queried. And then also to take this even further, a client itself can choose to check these proofs at runtime. And with Momoka, you again have all of the characteristics that you would want out of a blockchain and out of a system like this, but it's 1,000 times cheaper, around in that ballpark, like not exactly, but in that range, and it's 1,000 times more scalable in that range. We went from having an infrastructure cost that was absolutely insane to now, at this moment, around yesterday, I took this snapshot, around 414,000 transactions cost around $159. So at peak scale, Ethereum L1 would be sometimes, right, $50 for one transaction, right, something crazy like that. We have over 400,000 transactions now averaging at 0.0004 cents a transaction. And what this ends up meaning is that we can now start treating blockchain infrastructure like we treat AWS infrastructure and we treat Google Cloud infrastructure. So users can use these applications, they don't have to pay for the transactions, and the companies running this infrastructure can actually afford it. Bundler Network is on track, from what I understand, because right now they are at 50,000 TPS, and we've tested Momoka at around 35,000 TPS, moving to even more scalability. So I think 10x in the next 6 to 12 months, and then even more from that. So from what I understand, based on their architecture, because there is not this constraint, it is theoretically infinitely scalable, meaning that we will never kind of get to the point where we end up using this, because we don't have enough throughput to use up 35,000 transactions per second right now. So to kind of summarize this, how this works, the user signs a type data transaction just like they would have in the past. This gets sent to Momoka as opposed to sent to Polygon. The Momoka submitter runs the simulation. The submitter then saves it to Arweave. And then the verifier is kind of like listening for this update. And then the verifier either verifies it or does not. And if it is verified, it gets indexed. And then the APIs can then use that information to serve it to clients. So what are some of the statistics that we're seeing right now? So around 100,000 transactions in the past would cost $10,000. They now cost around $40. So we can say that it's around 250,000% cheaper. Also, the time, it's way, like much faster. So with Momoka, 50,000 transactions per second, it takes around 2 seconds for that to actually, to finalize. So we can basically say that it's around 165,000 times, like, it's more scalable, meaning that it actually is can handle more throughput and it's faster. What I want to do real quickly though, before I jump out of this, is open up. I'm going to open up Momoka. We have a dashboard where you can kind of see the transactions coming through in real time. What I want to do is take a quick picture here, and I want to show you how this works and how you can also run a verifier, because all this is like open source. Well, let me do this actually. Okay, so I'm taking a picture. I'm going to go ahead and post this to Orb, and then what you're going to see, like right here in a second, is like this post show up, and then we're going to verify that on my computer using the terminal. So I'm going to go to Orb. I'm going to post in the EthCC community here. All right, so I'm going to go ahead and click post, and I'm waiting. Okay, so now it's saving. Okay, so it looks like it just saved, and then now it should show up here, and I will give it a couple of seconds. I might refresh in just a second if it doesn't come through, but it should come through in real time. But it's been open for a while, so. And while that's saving, I'm going to go here to my Lenster. And there we go, that's the picture. I'm just going to refresh here because I think it may have lost connection or something like that. Oh shit, for real. There we go. Yeah, so there's Yaya. Actually, he was back here. There he is. he front ran me right there. And then that's me right there. And it says Orb is like the app. And then if we go here, we'll see the picture there. And what I can do now is like, Momoka is completely open source. The verifier and the actual Explorer are both open source. There's a Rust client and a Node client. So you can use this to not only verify, but you can also use this as an indexer. So if you wanted to index all the transactions that happen, let's say Lens shut down tomorrow and you wanted to kind of still run Lens, like it's still fully decentralized and in terms of being able to kind of still, or I would say it's open source and like it's not dependent on us as a company. So what I can do is just say Momoka, and I know that's really small, but that's bigger. And then now we're like running the verifier. So any new transaction that shows up, that happens will show up. So I can just go here and I can say Momoka. And then I'm going to wait for this transaction to happen. Oh, there you go. See, that was a lot faster. I'm going to take this transaction. Damn it. Where's the transaction? Oh, here it is. This transaction ID. It should be there somewhere. I'm actually running the Rust client, which is new, and I'm wondering if there's something bug in it or something like that. Yeah, let me just run the Node version. Yeah, we have like an experimental Rust client that's just faster, and I was trying to use that one, but damn. And anyone can run the client, by the way. You don't have to install anything. Like, you can install the Rust client, or you can just run npx. So I'm just going to run npx @lens protocol /Momoka. Oh shit! And I actually need to set the node with an alchemy node in this case, so it's not going to actually work. Okay, well, the Momoka demo failed because I wasn't able to get that. I should have set that up better. But anyway, if you want to learn more, definitely check out, I think most people got this already, the links that are here. You can go to the GitHub and check it out. And, sorry, let me get to my last slide here. There we go. Thank you. And if you have any questions, I'll answer some questions, I guess.
Thank you. I didn't quite understand. All these actions, do they end up on Polygon as transactions on Polygon eventually? And they don't. And with Lens v2, Stanley's talk mentioned that any smart contracts could be included by the community into Lens v2. How would this behave with all types of smart contracts, including, for example, swaps on DEXs?
Okay, yeah. So good question on the first one. Basically, the transactions actually do not go on Polygon unless they are a tokenized transaction. So basically, if it is someone buying an NFT or like paying someone or something like that, that would go on Polygon. But if it's just a data post, meaning you're just posting a comment or a picture or something like that, and it's not being collected, then it will go on Arweave with Bundler. So we're actually still supporting both. We support Polygon, and we're supporting Bundler with Arweave, and it just depends on the type of content. But we found like the average for the vast majority actually of the content is basically just posts that don't need to be tokenized. As far as the contract interactions, there's kind of two ways to interact with other smart contracts with Lens. So one is something that's already supported right now. It's through like an idea of a custom module. It would almost be like if you could submit a pull request to GitHub or, a pull request to like Instagram or Twitter. And they would merge your idea and then everyone would be able to have it to use it. So we already support that. That's through custom modules. And then with V2, the idea of these open actions is more like within the transaction itself, you're able to define a smart contract address and the interaction that's happening from Lens. So it's all bundled into a single transaction. And it can work right now only on Polygon network with other. But I think that I just talked with someone yesterday that was using like Axelar with Lens in order to do cross-chain stuff. So theoretically, you can do cross-chain, but it's not something that we've built out quite yet.
Thank you for the talk. My question is if you could give more context around the design decisions of choosing Arweave versus other data availability layers like Celestia or many others. Thank you.
Sure. I used to work at Celestia for like 4 or 5 months, and I really am interested in this whole space. So I like the question. And I think that right now, when I first joined Celestia, it was kind of like they were revolutionary in the thinking around like modularity and breaking up and more like, I would say, thinking outside the box in terms of data storage and data availability in general. And then since then, I think we've seen a lot of other ideas that are in the same vein happen and become, I would say more, people are aware of them. So we have Arbitrum Nova, who uses like data availability committees, and then you have EigenLayer, who's doing essentially a similar thing that Celestia is doing, but maybe like adding all the other components as well. And then you have Polygon Avail. I guess Filecoin could be considered in a similar like fashion, but IPFS is not because it's not permanent. I think the main characteristics we were looking for was permanence, immutability, and censorship resistance. And therefore, we wanted something that offered those, but also had a like long track record and history, and that was fast, and that was cheap. And like when you start adding up all of these different requirements, the number like of possibilities starts getting lower and lower. And we also wanted to go somewhere where there was a track record of it actually working. Celestia hasn't launched yet. EigenLayer hasn't launched yet. If those were available, they would have definitely been both options, I think. And because Bundler enabled like the really fast finality and the lower cost, I think it was like a perfect solution at the time. And I'm sure a year or two from now, we'll see better options or other options. But I think based on what was available at the time, that's why we went with it. Okay, cool. Thanks, everyone.